Hello and welcome back to JD's Science Prep. Today we will be discussing line structures for organic compounds. Today we are just going to be discussing the line structures for straight chain alkanes. Alright, so it says a line structure is an easy and quick way to represent an organic compound. Each carbon is represented by the end of a line or an angle in a chain. Hydrogen are not shown on line structures because we assume that single bonded hydrogens fill all of the carbon octets. Okay, so we have 4 examples here. The first one we have is ethane. So from previous videos, you should know that ethane will be C2H6. So C2H6, so we have to represent 2 carbon and 6 hydrogen with our line structure. So believe it or not, if I draw a straight line that just looks like this, that is the line structure for ethane. And let's discuss why. Okay, so up above, the description said that the ends of a line will represent a carbon atom. So each end, we have both of our carbon right there. And since each carbon has 3 hydrogen bonded to it, we can assume that the 3 hydrogen can be found attached or bonded to each carbon. Okay. So this is just a quick little diagram to show where the carbon are and where the hydrogen are. The actual line structure for ethane, like I said before, will just be a straight line that looks like this. Okay. All right, let's move down to pentane. We're doing something a little bit more complicated here. So pentane, we will start off with a line that looks like this. We have 2 carbon represented, and that angle right here will continue to represent a carbon. Okay, so now we have 1, 2, 3, 4, and 5 now. Okay, so let's just number them real quick. We have 1 here, 2, 3, 4, and finally at the end we have our 5th carbon. Okay, so let's represent where our hydrogen are now. All right, so this first CH3 group is going to be found on carbon number 1. So we have 3 hydrogen bonded to that carbon. On carbon number 2, we can see we have 2 hydrogen. So we'll represent it like that. On carbon number 3, you can probably guess, to fulfill carbon's octet, we need 2 hydrogen. On carbon 4, it's the exact same thing. We have 2 hydrogen to fulfill that octet. Finally, on carbon number 5, we need a CH3 group to fulfill that octet on carbon number 5. Okay, so again, I will redraw what pentane's line structure actually looks like. So again, it'll be 1, 2, 3, 4, and 5, just like that. Okay, so this is pentane. All right, next up we have heptane. We're getting a little bit more complicated again here. So we have 1, 2, 3, 4, 5, 6, and 7. Let's go through our carbon and hydrogen again. So our carbon, we have 1, 2, 3, 4, 5, 6, and 7. So notice they're found either at the end of a line or at an angle in a chain. Okay, so we have a CH3 group at the end of 1, a CH2 group on 2, another CH2 group on 3, and that will repeat from carbons 2 through 6. We have CH2 groups. Okay, and at the end on 7, we do need that CH3 group. So you kind of start to see a pattern here. It does line up quite well with our Lewis drawings as well. Okay, so let's redraw heptane and we'll get into methane. So we have 1, 2, 3, 4, 5, 6, and 7. So heptane and its line structure looks something like that. Now, finally, you may ask, can I draw a line structure for methane? The answer is no, you cannot. Okay, and the reason for that is because you only have one carbon, so you cannot actually draw something that looks like this, because this represents a carbon being at both ends of the bond. Okay, so no, because there are no carbon-carbon bonds. Because there are no carbon-carbon bonds. Okay, if this video has helped, please like and subscribe. Thank you very much.